Okay, permutations. But before I start talking about permutations, we'd like to know what ordering is. Suppose you have 3 items, so let's say n is 3, and say the items are A, B, and C. So the question is, how many orderings or arrangements are possible? Now in this case I can write them out and count them. So I could say A, B, C, that's 1. A, C, B, that's 2. B, C, A, 3. B, A, C, 4. C, A, B, and C, B, A. So I can easily count and say 6 ways. Oh, that's not difficult. Why do I need math for this? I could just count it, right? But it is easy, and you're able to count the number of ways because n is small. But suppose instead of 3 items, suppose let's say we have n equals 26. We have letters A, B, C all the way up to Z. Then in how many ways could you order these? So how many orderings are possible? Well, you can work hard and write everything out. It might take all eternity, or you can just realize that this is nothing but n factorial. So it is 26 factorial, which would just give me an answer of we're going to make use of a calculator. So 26 math over to factorial and press 4. That many number of possible ways. So approximately I could say it's 4.0329 times 10 raised 26 ways. Well, do you think that you could have written all of these possible ways out? Think about it. You could not have written that out. So knowing that the number of possible ways to order n different items could be calculated by a factorial helps us because we can actually put that in the calculator and get an answer. So in my original case, the simplest case that I have over there, if n is 3, 6 ways is nothing but 3 factorial. So I could just write it as 3 factorial. 3 factorial is nothing but 6. N there was 3, and I get 3 factorial 6 ways, so I didn't even have to write them out, I just know the number of possible ways. Moving on, instead of just writing number of possible items, number of possible orderings if you have n items, suppose you have n items and you pick all items from the n items. So how many possible orderings are there for the R items? In other words, suppose I start with n equals 4. And let's say I have the items A, B, C, D, and I pick 2 out of these n items, so R is 2. I do not know what the 2 items are. There are several possibilities, so you may say, well, why not write them all out? You could write it out as AB, AC, AD. Keep in mind, we're looking at orderings, so AB is not the same as BA, AC is not the same as CA, AD is not the same as DA. So I have 6 possible ways now, and then I'd have BC, BD, CB, DB, CD, and DC. So in total, I have 12 possible ways. This is quite easy, you might argue, but I knew that this was 12 because I counted the number of possible ways. I wrote them out, then I counted them. But this is not realistic if n is huge. For instance, suppose you have 40 and you pick 2 out of those 40 items, there is no way that I could write them all out. There has to be a better way. And that approach is nothing but a permutation. What we did here can be done using NPR. The P stands for permutation or permute. So if you choose R items from n different items, how many permutations are possible? Well, it's quite straightforward. If we use the formula in that case, n is 4, R is 2. NPR is a simple formula given by n factorial over n minus r factorial. So 4p2 is just 4 factorial over 4 minus 2 factorial, which would just give me an answer of 12 if you plugged it in the calculator. If you look on the left hand side, I could do the same thing using a calculator. I'd have 4 math over to PRB factorial divided by 4 minus 2 math over to PRB factorial, and the answer is 12. So this is neat. I could use a calculator to find the number of permutations if I pick R items out of n items. But there is also an easier approach. The calculator could take all of this formula for NPR and do it in one single function. So if we want to find 4p2, what you can do is press 4 math over to option 2 that brings us NPR, then press, it has to be a 2, 4p2 is 4 NPR2 on the calculator, and I press enter, I get the same answer. So suppose in a similar manner, if we want to find number of possible orderings when you choose 6 items from 30 different items. Well, so n is always the bigger number. N is 30, R is 6. You can say, well, I'll sit and write them all out, but it's not possible unless you have no life, or you might have to spend all eternity, as I mentioned earlier, to write all possible ways out. So the better way is to write it as NPR, which is 30p6, which would be given by a formula n factorial over n minus r factorial, which would be 30 factorial over 30 minus 6 factorial. And we can find this answer using the calculator as follows. And those are the number of possible ways. So you can't tell me that you could have been able to write, let's say it is about 427,518,000 ways. As I said, it's impossible to write them all out, then count them properly. So I showed you one approach, but an easy way is just to use 30 MPR 6 in calculator. So that will give us the same answer. So if you look on the left hand side, I could just press 30 followed by math over option 2 followed by 6. Press enter, I get the same answer. It's 427,518,000 ways. So you can use one of these approaches to find the number of possible orderings when you select R items from n items. So more precisely speaking, this gives us the total number of permutations when we select R items from a set of n different items.